Everyone, thanks for coming to this presentation. My name's Grant and this is Chris. So before we get too deeply into the presentation, I just wanted to talk a little bit about what the agenda is for this presentation, just sort of go over what we're going to be talking about, just to make sure that no one's wandered into the wrong session, hopefully, and to make sure that the content's going to kind of hit the mark for you. So we're going to be talking about a process we've been through recently of taking an existing client-server application and moving that up into the cloud, up into the Azure platform to be specific, and creating a SaaS product offering from that. Okay. So what we're not going to be doing is talking about a lot of code. We're not going to dig into a bunch of APIs in this presentation. We're not going to be doing Visual Studio code demos or anything like that. However, we will be digging quite deeply into some of the technical decisions we've made along the way. We'll be talking about things like strategies for managing data, multi-tenanting the databases and stuff like that. We'll be talking about strategies for handling performance, reliability, deployment, all those sort of things you've got to think about when you've got a desktop application in the mix. And we'll be looking at quite deeply at the final architecture that we ended up with, at the solution architecture, looking at that quite closely and how we've implemented things up in Azure as well. So this is a real-world example. We do have a live application that's been running up in Azure for about 6 to 9 months now. And we're hoping that this is going to be relevant for anyone who's sort of considering doing the same thing and looking into this sort of expedition like this. So both of us up here are pretty technical guys, so if anyone wants to dig into stuff more, query stuff, drill down into anything, we can talk about it after the session. We've also got Stephen up the front here, who's our lead developer. He's going to be around, floating around TechEd as well, so if anyone wants to grab us at any time, that's cool. We should be here to help. Okay. So before we get too deeply into it, I wanted to just give you a little bit of context, talk a little bit about who Vista is and what we do, just to sort of put a bit of a frame around it. So we're a local ISV. We're based here in Auckland. We design and develop all our software here. And essentially we create software that helps cinema owners sell tickets and popcorn at the base of it all. So it's quite a nice little industry to be in. So cinema owners are the guys that show the movies. We're talking about people like Event and Hoyts, etc. Okay? At the heart of our system is a Windows desktop application. So it's a client-server app, retail point of sale. And of course, being a POS system, this thing's got to be super fast and super reliable. Okay? It's got to integrate with a lot of hardware, barcode scanners, thermal printers, digital scales, stuff like that. It's been a work in progress for over 15 years, so we've been working on this product suite for a long time. Okay? So our POS is really flash, it's really fancy, it does a lot of cool stuff. It's kind of the crown jewels in our system, and it's sort of one of the key reasons why a lot of customers choose Vista is because of the POS. That's not the only thing we do, of course. Over the years, we've developed a whole suite of complementary products that go around and support that core cinema system. So stuff in here like we've got a full loyalty system that we've built ourselves. We've got a vouchers and gift card system for managing movie money and rechargeable gift cards, stuff like that. We've got a full self-service BI stack built on top of a data warehouse. We do lots of stuff. We've got every kind of ticketing app you can imagine. Okay, we've got an IVR system for ticketing. We've got touchscreen kiosks. We do iPhone, Android ticketing, all that sort of stuff. And we integrate to lots of equipment down at the cinema as well. So our software drives things like the digital projection systems, also LED signage, digital signage, big plasma screens like you see here, all this sort of stuff. We do all that as well. We even control the air conditioning in each cinema based on the number of bums on seats. So we do a lot of software, basically. We kind of create an entire ecosystem of software for managing a large cinema circuit. But at the heart of it all is that point of sale. So who buys this stuff? So we sell Vista locally, of course. If you buy a movie ticket in New Zealand, chances are you'll be going through Vista software to do it. But we've got customers in 56 countries around the world. We operate in 13 languages Vista operates in. We'll put about 800 million box office ticket sales through Vista software this year alone. In terms of growth, we continue to grow year on year. We'll see 2 new cinemas installed on average every day this year somewhere around the world with Vista software. So that's great for us, but I'm not really here to brag about how great Vista is. We do have about 23% of our target market nailed, which is great. But that's where the important point is here, is that our target market is really those larger cinema circuits, okay? These guys who have 20 or more screens in their circuit, that's really the sweet spot for Vista where we aim at. Now, these guys cover about 66,000 screens around the world are included in this market bracket. But the total number of cinema screens around the world is anywhere from about 150 to 200,000, depending on how you count them in China. Okay? So what this means, essentially, is there's lots and lots and lots of little guys out there. So you can imagine what's going on in this place, okay? There's not a lot of IT infrastructure here. There's no IT guy, there's no server, okay? And these guys are all the little operators, and there's obviously thousands of them out there, okay? And of course, the core Vista system is just, it's really kind of overkill for these guys. Vista comes with some infrastructural requirements. We need an instance of SQL Server, we need an application server to host that, we need networking and all that sort of stuff. And these guys just aren't interested in that stuff. Really, the barrier to entry for these guys is a little high. Also, you've got to consider things like training. Vista's a pretty sophisticated system, right? So, you've got to train your staff when you purchase it. Even just the pricing model, you've got to pay for a Vista license up front. And so that just makes it a little hard for these guys. And this is where we saw the cloud come into the picture for us, okay? We realized that if we could take some of that infrastructural headache out of the equation, move some of the infrastructure up into the cloud, we could actually tap into this market. So this is what we decided to do. So we refocused and built a new product altogether called VZ. Now the marketing guys tell us that this stands for Vista Easy, so take from that what you will. They probably get paid more than I do. But easy really was one of the key words that we decided we needed to focus on, okay? We had to make this easy to find online, easy to adopt and try out, and super easy to use, of course. But it couldn't just be easy, it also had to be reliable, had to sort of bear all the traits of our existing system. It had to be super reliable, super fast, okay? You're selling tickets, network goes down, you can't stop selling tickets in a cinema. This is a core part of the business, okay? So that's effectively what we did. And I think that's an important point here, is that we didn't just try and take an existing application and kind of move it wholesale up into the cloud. We focused quite carefully on the market we were actually aiming for, and we realized that we could actually trim back the feature set in order to be able to do that, because these little guys didn't need all the complexity of the full system. And that helped us solve some technical problems further down the line that Chris will talk about. Okay, so where did we start? Excuse me. What you see here is this is what we now affectionately refer to as Big Vista. Okay, this is the big brother. This is our existing product. And this is a kind of schematic view of what a standard Vista cinema install might look like for a circuit, a reasonable sized circuit. Okay, so you can see, I guess there's a bit of complexity here. There's a few moving parts, a few interactions. None of this really matters for this presentation, apart from the fact that in general we could dismiss all of this and throw a lot of it out of the door. Okay, except for two really important parts. So we retain the point of sale, and we retain the core database schema that runs on. We took that database and basically just moved it up into the cloud and got it out of the cinema's domain. Okay? So, we're going to retain our POS. The other key decision we made along the way was we only want to have one body of source code. We don't want to have one POS for Big Vista and one POS for our VZ product. Okay? So we wanted to minimize the code changes we were going to make as well. So that was another key strategy that we had in mind. And minimizing those code changes. I mean, our POS was originally written over 15 years ago. It was originally written in VB3 back in the day. So it really is a client-server app. It's got lots of SQL statements embedded in the code, knowledge of database transactions and stuff like that. So it really is a client-server app. So effectively, it was wedded very tightly to the database schema. We didn't want to throw that away. So we knew we had to keep that core schema. So what we did is we basically, to minimize the impact on our POS code, we injected a provider layer directly behind the existing data access layer that we had in POS, and that allowed POS to continue on blissfully unaware of the fact that its data source is now some 12,000 kilometers away in Texas. Okay? And it connects up to a WCF server sitting up in the cloud next to the data store. Right? Next thing we had to do was provide a back office system as well. So we could have taken the Big Vista system here and pushed that up into the cloud as well, but the reality is that our Big Vista system is just too much for this market as well. So we have about over 150 maintenance screens in our back office application. There's 200 plus Crystal reports in that app. So that was just overkill for this product as well. And we also wanted the back office app to be ubiquitous and accessible anywhere. So our target user is slightly shifted here from being a duty manager at a cinema to being the cinema owner. Okay? So we wanted to be able to get to it anywhere, so we wanted a browser-based app to achieve that. So we started from scratch here and built an entirely new browser-based back office management app. And this is built from the ground up to be multi-tenanted and to run in the cloud. So it's cool. And of course, finally, we had to get paid. Okay, so every good SaaS product needs a way of managing customers and accounts. You've got to do authentication and authorization, of course. We wanted the system to be really easy to get on board with quickly, so we wanted to be able to auto-provision new customers along the way, and we do all of that out of the client management system. And this guy really just brings everything together for the other systems. Okay, so that's a very high level sort of schematic view, as I said, of kind of where we started and where we got to, and hopefully that'll put a frame of reference around things that you can pin the deeper information that we'll get to as we go through. So once we'd established the big plan like this, we had to figure out exactly what we were going to do in terms of which cloud we were going to select to actually host this thing on.
Thanks, Grant. Okay, I'm not used to standing around and not saying much, so I'm going to gather up that position from a little bit from now. Okay, Vista is completely a Microsoft shop. Okay, we knew roughly what VZ was going to look like at a high level, but we needed to figure out what shape it was going to take on the different cloud platforms and the different offerings that were out there. So we rapidly narrowed down our offering, our different choices down to between Amazon Web Services, so down to the EC2 infrastructure as a service offering, and also to Azure. But also, just for completeness, we added dedicated hosting in there as well, because we thought we might do this whole thing ourselves and roll it out around the world. That conversation lasted about 16 seconds before it got binned, because trying to do that kind of stuff yourself is just simply too hard, and getting global scale is too difficult to manage. So in order to understand what VZ was going to look like on these two different cloud offerings between Amazon and Azure, we needed to have a big list of assumptions and model out what VZ was going to look like over the next 24 months as far as uptake and rollout was concerned. So we needed to know how many clients were going to take this up, where the cinemas were going to be, how many POS terminals they were going to have, how many users they were going to have, what their usage behavior was going to be, that kind of thing. Now, you may think you can put those sort of assumptions together in about 10 minutes. You can't. You need to spend days working on this stuff, and you need to spend time working with your marketing and sales guys figuring out what they're planning, okay? Because you need to plan for success, because if you don't plan for success, you can guarantee failure. Really simple. So we got this big list of assumptions together, okay? It was about a 7 or 8 page Word document, very tightly bullet pointed, and we used that to shape up what we would be looking at for VZ on Amazon and VZ on Azure, okay? Now, on Amazon, being an infrastructure as a service offering, we could have kept an awful lot of the big Vista client-server infrastructure and architecture. We could really have ported a hell of a lot of it very, very quickly and got up and running really quickly. The problem was scaling the database tier was going to be a nightmare of epic proportions, okay? And also looking after the infrastructure, just the patching management and making sure the wheels keep turning was going to effectively turn Vista into something of a small infrastructure company. And that's just something we don't do. But we did cost it up. We went through the entire due diligence process, and it turns out that Amazon, the total cost of ownership on a per month basis was going to be 300% that of Azure. And that was almost entirely to do with the human beings that needed to keep the wheels spinning. So Azure turned out to be the sweet spot for technology because we're already an MS shop. Scaling was easy because we could really leverage SQL Azure to make sure that we had that underpinnings at the data tier to work for us. Okay, and cost, third of the price, there was really no argument around that. Now, it's really important just to reiterate how important it is to make those assumptions, model your costs, and get it right early on. In fact, we're pretty good at this because we ended up getting within 5% of our actual costs on a monthly basis, and we estimated higher. Okay, so it's really useful stuff. Now, we'd made a decision. Okay, it was going to be Azure. So the very first thing we needed to do, as Grant mentioned, because we were going to keep our DB and our schema and a whole load of SQL that was buried within various apps and stored procedures and so on, was it actually going to work? Okay, or was there going to be a large truck driven through a whole load of the code we needed to look at? Now, the first 4 bullet points, select into, explicit temp DB references, XML and text handling, stuff there that SQL Azure just doesn't support. Sorry, the Windows Azure SQL database. I can't get SQL Azure out of my head. Some of that stuff's going to be important to you in your code, and some of it won't be, okay? If it does matter to you, deal with it really early on, and don't make assumptions it's going to be easier to deal with. The one that bit us here was the select into, okay? Big Vista supports multiple collations for different users around the world. And to get around that within certain stored procedures and SQL batches, it uses select into to respect the collation settings of DBs and columns and tables and so on. Can't do that in SQL Azure, okay? So we had to make a decision up front. Are we going to do the heavy lifting and the hard yards to figure out how we do that without using select into, or do we just make the really easy decision and say, if you're using VZ, you're using precisely one collation? Yep, we went that way. Don't make life hard for yourself because you're going to run into difficulties in other places anyway, okay? So right now, if someone comes to us and says we want a different collation, we say, yep, Big Vista, just around the corner. You can go and use that, okay? We may change that in the future, but we didn't need to deal with that up front. Time zones. On day one, if you're going to go to Azure, change every single one of your local SQL server's time zones to UTC. Okay? Don't wait. Do it on day one. The reason being that obviously SQL Azure runs in UTC, so for the SQL people in the audience, that means get date and get UTC date, return the same thing. Yep. And you'll find out if there are any assumptions made in any of your software anywhere that relies on one time zone being used for one deployment. And yep, that bit us big time. Strangely enough, there was an assumption, quite reasonably, that there was going to be a POS within the same time zone as SQL Server. And considering you're normally 50 feet away on the same LAN, that's not a bad idea, not a bad assumption. Kind of bad when you're talking 12,000 kilometers away in Texas. Okay, not a good idea. And of course, you can imagine if you're on POS and you're trying to figure out what films you can sell tickets to and what the sessions are coming up, if you're trying to use a server-side date to figure out what's going to be displayed, not the greatest experience in the world. Okay, so sort out your time zone handling very, very early on. Also, if you've got date time columns in your DB, you're going to have them. Yeah, agree up front and once what sort of date time you're holding. Is it a local one or is it a UTC one? Okay? Don't make assumptions that everyone knows that this column on this table has got UTC data in it just because you know about it. We actually went through this process and every single column that's got a UTC date in it in the database now that we use has got a UTC either prefix on it. Okay, so you've got to make sure people understand what sort of time zone data is being stored. SQL Azure doesn't support the same backup strategies that you've been using. Okay, so understand how you're going to back up your client DBs. Yep, you've got very, very good fault tolerance on SQL Azure as it stands. Okay, that does not stop someone trashing your DB by running in the wrong script. All right, and you need to be able to get that stuff back. We use backups to backpacks that are stored in blob storage. Okay, big thing here, and this is the same as if you're doing it on premise. Test your backup strategy, test it again, test it to death, and then make sure you can restore from your backups. Okay? If you're using something new like backpacks, make sure you can restore them on premise as well as off premise back onto Azure and make sure it works. Okay? Get that stuff running up front. Also, there's no Azure compatibility mode for SQL Server at the moment. Okay? There may be one in the future. You can't change a local SQL Server instance to run in Azure compatibility. So you can still do stuff that's going to break your deployment to Azure. Okay? Get used to running the migration wizard repeatedly and repetitively, okay? To make sure you're not doing stuff that as you go along, that when you get to that urgent release you need to make, all of a sudden you can't because you've got a whole load of stuff that's been put in place. Right. So we understood that we could fix what we had as far as databases was concerned, but we now needed to figure out how we were going to deploy our databases for usage within VZ.
Okay, so first big question we had to ask ourselves, and this was a really big one, we talked about this long and hard for quite a while at Vista, was whether or not we were going to try and multi-tenant our existing database schema. Okay, and this is a big issue to consider if you're going to go down a similar path. And so multi-tenanting really is the standard approach. It's the default option for a SaaS application, and I guess that was our instinct. We thought that was what we were going to be doing. But once we started digging into what that actually meant, we realised it was actually a bit of a process to go through. It was a bit complicated. We assumed that it was just going to be a case of injecting some client keys into a few key tables and then modifying your app code to deal with that. Turns out it's not that simple. Okay, so one of the reasons for sticking with one big database in the sky is you get economies of scale, of course, so it's obviously a good option, and also you get the ability to reuse data. Okay, so you can share data across different customers. Why should everyone in the States have the same a replicated copy of the record for popcorn, for example, when that can be shared? So that's one of the great reasons you want to go down that path. But what we found was we wanted to be able to share some data, and we wanted some data to be customizable by client. Even within a single table, we wanted some fields to be shared across customers, and we wanted some to be customizable. So we realized pretty early on this was going to be like driving this truck through our application code. It was going to be a major re-engineering of the understood data relationships in the system. There was a couple of other reasons why we started to shy away from this approach as well. You've got to think about language and collation. Okay, so if you do have shared data in one massive database, what happens with the record for popcorn? What if it's called something slightly different somewhere, for example, in a different language, obviously? So you've got to think about that, collation as well. Performance is another big one. We were looking around and we were finding a lot of people were talking at the time about, I've got this massive database in the sky, how do I partition it up now because I need it to perform better or I need to be able to manage it better, right? Okay, so trying to pull data out of an existing large database schema for different partitioning approaches and then put them into different partitions could be really hectic. You can imagine how much of a nightmare that would be. And we realized that we already had a natural partition we could use. So the option we went with is to have a database per customer. Okay, so this is a bit of a shift for Vista. Normally we have a database for every cinema site. So Queen Street will have its own database, Broadway will have its own database, for example. So we modified that. We just allow every customer to have as many sites as they like. So there's a little bit of tenanting going on, but it wasn't massive. And this really was the sweet spot for us. We didn't have to change a lot of code. It really was just a case of putting a few client keys in. And we'll come up with a bunch of other advantages that we've seen come out of that as well, which are quite interesting that we thought we should talk about. So firstly, of course, every customer's data in this model is discrete and private and isolated. Okay? So that leads to some quite nice advantages. For a start, you don't have to worry about privacy. You don't have to worry about data leaking, which you would have to do with one large database. You can manipulate the data quite easily and safely. You don't have to have any impact on any other customers. So we can do archiving, which we actively do, and you don't have to worry about how you pull out the data that you're going to destroy and archive it. It's pretty easy because everyone's isolated and discrete. You can even take a customer completely out of the cloud and convert them to an on-premise model and get away with that really easily without impacting anyone else. So it's nice. You get that kind of customer portability, if you like. We also have tiered version support, so we can take a risky update and pick a subset of customers and roll out the update just to them. Doesn't impact anyone else. Okay? So that's quite a nice feature. It also aligns nicely with the infrastructure. So up in the cloud, you know, you're not renting big iron up there. It's a scale-out model, not a scale-up model. So it just fits quite nicely with lots of small databases. Actually fits in with that quite nicely. And so the features in SQL Azure, or should I say Windows Azure SQL databases, around replicating your data and the dynamic performance management for hotspots in the database servers and stuff, all works at a database level, so it fits quite nicely with this partition. Okay, the other thing we found also, of course, is that because we hadn't driven a truck through our application code, all of our other existing subsidiary tools that we use at Vista just carried on working, which is great for us. We can take our existing large back office application, poke a hole in the firewall and connect it to one of the customer's databases and manipulate stuff if we have to, and it all just works, which is cool. Now, of course, there are some cons as well. There's some costs or some negatives associated with this approach, right? The obvious thing is you just end up with a hell of a lot of databases, right? And there is some pain associated with that, and we thought about this quite carefully before we went down the path. Obviously, cost. It's going to cost you more money to have hundreds and hundreds of databases than to have one big one. Okay? We offset that a little bit by actively keeping every customer's database quite small, so we do actively archive their data. And when they sign up, we explain exactly what our data retention policy is, so they're clear on that. And that keeps the cost down. Maintenance is another one. Of course, you're going to have to run scripts, you're going to have to do backups, as Chris said. You know, you have to run upgrades and stuff like that. And if you've got hundreds of databases, that's a bit of a headache too. What we've done there is we just spent $500 and bought the Redgate multi-script tool, and we've actually found this is actually fairly pain-free. It's not as bad as it sounds. The other thing is you don't get shared data in this model, okay? So every customer has a copy of the popcorn record, right? What we realised is that this was actually kind of mildly painful for us because we've got a little more data to store, but it's really painful for the customer, okay? It's all about the user experience here. They've got to create a record for popcorn. They've got to create a record for Batman when the guy down the road is showing the same movie. So what we've done to mitigate that problem is we created a content services system as well. So we have reference databases that have all that stuff in there for them. We create all those records for them, and we line up all the concession images so the buttons look great on pause, and we include the film poster graphics and that for them. We create all that data, and when they want to schedule, they just pick one of the movies off our stack, and it copies that record down into their database, and away they go. And this way, they can manipulate that data as much as they like. They can change the recipe for popcorn without affecting anyone else. So for us, this has actually been quite good. So not multi-tenancy in the database was a bit of a sidestep from the kind of classic Cloud Application 101 playbook. And the other big thing we did was to retain the desktop application, as we mentioned, as part of the solution. Now, if you're going to go down a similar path, we've identified three kind of big things that we had to deal with, okay? One of them is performance, okay? Obviously, taking the database and moving it from the back room to Texas is going to hit you in the performance pocket, no doubt about it. Latency becomes your arch enemy. Reliability is another one. So you go from operating on a LAN network to operating over a domestic DSL connection with an ISP in the middle and stuff like that. Reliability is just going to get hit. And the other big one is deployment. Okay, so the beauty of having a web app as your core part of your core cloud solution is that you've got that near perfect deployment story, of course. With a desktop application, you've got to think about that. You want to make sure that that story is really nice, that the user can transition from being in your cloud experience to installing something on their desktop and feel good about that and not feel afraid. Okay. So anytime you try and do anything and make it, yeah. Sorry, I've wandered off topic there, Chris. The first thing we want to talk about was performance.
Thank you, Grant.
Sorry.
By the way, we actually had an agreement that if we wandered off topic, we rugby tackled each other to make sure we stopped. Okay, right. Performance-wise, on day one, obviously, we didn't come into this cold. We knew roughly how chatty POS was with the database. So we had SQL Profiler running. We saw how many database hits the client was making on certain things. And we basically focused on a few key pieces of user experience. The number one thing we focused on was what happens when you press the Add Ticket button on POS. Okay, so I want Batman, 1 ticket, thanks. Up front, we knew this was 15 database hits. Now that you can live with that if you're on a less than 1 millisecond round trip to your DB in the back room. You absolutely can't live with it in any other scenario. So what we did was we used some utilities, example being TM NetSim, to actually install some latency on the local network. So we could pretend we were long lining the database all the way to Texas and tweak things, but without actually doing it. Okay. So we ran this up and we demoed it to the entire exec team to get them over this idea that this is going to be easy. Okay, because when you press this button and it's 15 dB calls going halfway around the world each time, the experience is pretty dreadful at that point. Yeah, and everyone gets this crashing moment of reality going, oh God, here we go. Yeah. Now, what we found out was that no matter what we did, okay, we could optimize this thing to death. We were never going to get enough performance out of it without making some functionality trade-offs. Okay, basically we had to take a knife to some of the functionality within POS, so that everything that the current Big Vista POS did, some of that stuff has to go away. We documented that way up front. We got rid of it. Okay, and we've never revisited it, and that's been fantastic because it means you don't have to keep on going over and re-legislating the same decisions again and again and again. So make hard decisions up front, then you know how big the problem is you're looking at. As soon as you're running using web services, using one of the debugging proxies like Fiddler or Charles is your friend. Okay? You must have this stuff running so you can see what's going over the wire at all times. Don't rely on log files that your different satellite assemblies might be writing to at different points for a couple of reasons. Number one, it's too easy to miss stuff. Okay? Things just get executed and you've missed them and you have no idea where they are. Number two, if you've got a number of log files, it's a really, really hard thing to do to figure out what's going on as far as a time order sequence is going on over the wire and so on. If you're using Fiddler, the whole lot's just right in front of you and sitting there. You can record these traces, you can play them back without the app running, you can compare them to other traces later on, and you can see what sort of performance benefits and things you've made, okay? It's a really, really useful tool to get used to it. Now, the vast majority of our clients were going to be running over domestic grade DSL. Okay, so we went out and we got domestic grade DSL installed into the client, into our office. However, then we performance tested using the domestic grade DSL, and of course, what do you know? It's faster than our corporate LAN. Okay, now it's faster in most cases, but the jitter around the latency, around the ping times, varies dramatically compared to the corporate side. Okay, so the corporate side is actually really reliable and stable. The domestic one all over the show. Okay, however, when it's going like clappers. Okay, it's fantastic stuff. But we realised we could actually get the sort of performance we needed out of this. And at this point, we identified exactly what the magic number was, and the magic number was 300 milliseconds. As long as we gave response back to the user when they pressed the ticket button within 300 mils, because remember, most of this stuff is touchscreen, so you reach out, press the button. As long as you've got 300 mils and you're back running again, that's good enough. So we chased that number with absolute no mercy whatsoever. As long as we could hit 300 mils, we were going to be laughing. Now, as soon as we had our endpoints deployed onto Azure, we needed to make sure that the network routing was reliable and it was actually sensible. So we trace routed to every single one of the endpoints that POS or any of the other applications was going to hit. Now, we found dramatic differences between ISPs within one country. So make sure you trace route to all of the endpoints you're going to use. If you see anything even slightly weird, tell Microsoft and they will sort it for you. Okay? They spoke to ISPs for us and they got them to alter their routing tables. If you go and talk to ISPs and ask them to alter their routing tables, good luck with that. It's not going to happen. Microsoft can make this stuff happen for you. Microsoft also fixed some routing inside their own network to make it more efficient from the entry points we were coming into. Okay? So they've saved us milliseconds here and there, and that counts when you're doing this stuff. So get Microsoft involved really early. Also, if you get them involved early, they understand and know what you're doing and how your application works. Okay? So then when you have a problem 3 days before going live and you need them to help, you haven't got to explain the whole damn thing from the scratch and to get them up to speed what to do. They can help you really, really quickly. So talk to these guys early. Now, understanding your scale points is the number one lesson in the cloud. Your application absolutely will not scale as one big monolithic block. Okay, don't try and do that. For us, our only important scaling point, realistically, was our web services, the WCS web services that sit behind POS. If back office gets a bit slower as more and more load piles on, yeah, not too bothered if it takes someone an extra half second to schedule a film for 3 weeks out next Tuesday. However, 300 milliseconds doesn't go away even when the load comes on, especially as a blockbuster opens in the States and 500 cinemas start selling tickets at the same time or roughly the same time. So we scale there very aggressively. Okay. Now, the biggest enemy, as Grant mentioned, is latency. Okay, light ain't getting any faster. So you need to deal with your latency really, really early on. So we optimized, we used stored procedures at the database level. We cut down the number of database calls. We put the database into SQL Azure and we ran POS locally. We got it all running. It was less than 300 mils on the ticket click. We thought we were home free. We thought we're done here. We brought our WCF web services in, plugged them in, and bang, our performance collapsed by 100%. We were twice as slow over WCF than we were over TCP connections directly to the database. There was much panic in the office. It was very quiet for a while. And then we started looking in anger about what we were going to try and do to fix this thing. Now, we looked at our WCF stuff because we thought, right, the only thing we've changed is WCF, so therefore we must have broken something somewhere. It must have been stupid. It wasn't that, okay? Because we'd started to notice that our HTTP GETs were not having the same performance problem that our HTTP POSTs were. We raised this with Microsoft. We did more trace routing. We did a lot of trace routing, believe me. We looked in everything we could find and we found nothing. Okay, we got down to the point of using Wireshark to look at the wire level traffic, and believe me, it's fun when you get down to using Wireshark and you're sifting through stuff looking for something you don't know what you're looking for. But eventually we found out we're actually going over the wire twice for every single one of these requests, literally transiting twice, okay? Which is, of course, why we had twice as long delays on our usage. Turns out the culprit is expect 100 continue error, which is by default on in .NET for all HTTP posts when you make it from a web proxy or a web client, okay? Now, the idea behind this header, expect 100 continue, is to prevent a web client, a web service client, posting a really big payload when the information in the headers that it's going to send was good enough to either reject or accept the request in the first place. Not much point posting a 2 meg file if your authentication credentials in the header were wrong, okay? So it sends the headers first, web server goes, yeah, go on, and then you send the body and it comes back again. Great. Great if you've got big payloads. Absolutely fatal if you've got really small payloads like we have. We've got 1.5K average payloads from POS with a really long line and a really big latency problem. So it's a killer for us. It took about 30 seconds to fix. It's setting the expect 100 continue property to false on the service point manager. Bang, you're away and you're up and laughing. Okay, that's now made it to the Microsoft FAQ list apparently for long-lined or highly latent web service usage around the world. Okay, it's one of these things took weeks to find, 30 seconds to fix. Okay, so understand that one. The two images you can probably see on the really small screens in front of you. If you see in Fiddler a really long elapsed time between the client begin request and client done request, you're probably looking at an HTTP expect 100 continue problem. And there's the little critter at the bottom. We can actually see the expect 100 continue header there. Okay, so we had performance in the bag at this point. Now we needed to make sure this thing kept on trucking and didn't go up and down like a yo-yo. So before we deployed anything else to Azure, we had Pingdom set up, looking at some Hello World pages sitting in the data centers around the world where we were going to end up deploying VZ, because we just wanted to see how fast Azure was globally. We found out from that it all looked good. We could get enough performance out of Azure as a data center and from global points of presence that we needed. Now, as soon as we had our actual Azure app, VZ app deployed to Azure, we of course just turned Pingdom to stop looking at the Hello World pages and start looking at our real pages on VZ. And we found out on the left-hand end of the performance chart, you can see down there, our performance was about 250 mils round trip. So we're thinking, brilliant. Then we realized we hadn't actually done enough, because all we were doing is replicating the end user experience. We weren't hitting the entire stack to figure out whether something was actually going wrong. So we ended up writing bespoke test pages that exercised as much of the stack as we possibly could. We didn't use caching. We didn't leverage any optimizations. We basically went top to bottom of everything in every single request, which is why you can see the world's worst performance chart with everything getting slower over time. Okay. What it means is we're actually exercising more and more of the stack as we turn on more and more parts of the test. The great thing is that Pingdom, which is a dirt cheap service, about $40 a month, is not only looking at performance, it's alerting us if any single part of our stack goes down, and the best thing about this is it keeps every part of our stack warm. So it stops Azure recycling any resources whatsoever at any point because they look like they're not being used. They're not. They're always being used. Every minute they're getting hit, bang, 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 it keeps on going. So we understood what Pingdom looked like, what our performance looked like. We understood that it was going to be reliable, and now we get alerted whenever anything bad goes on. Great. When things do go down, and they do, We needed to see what the pattern, what it looked like around what those outages were like. Were they short, long, frequent, infrequent, and so on? And we found out by using some test rigs that we were ran in-house and just pinged mercilessly all of our endpoints as fast as we could. We ended up having the vast majority of our outages were very, very short, usually less than 300 mils, basically within that retry kind of window. A few sub 5 seconds, and then a very, very few that reached beyond 5 seconds up to the 30-second mark. So what we wanted to do is figure out how to deal with those without scaring the life out of the client every single time. So, sorry, I've gone on. There you go.
So first thing we did to sort of adapt to this new reliability profile was we built fault tolerance into that provider layer that we showed at the start. So we just found that just with a gentle retry every now and then up to a reasonable sort of timeout period, we could smooth over a lot of those glitches, and the POS operator is basically blissfully unaware that anything's going on. So that was a key thing to include. The other thing we did was to look quite carefully at the user experience around it. So you've got to accept that stuff's going to go offline, and it's just going to happen. Heaven forbid the Azure data centers do go down. Okay. So one of the things we built into it was fairly intelligent error handling. So we do look to detect where the issues have happened. We look at what's going on in the data center, and we compare that to, we contrast that to when just a general internet connection issue comes up. And we inform the user, and we try and sort of hint at some things they could do about that. So we did really focus on the user experience side of it. The other thing is when we come back online, we really sort of hardened that up in Vista, and we made sure that everything came back online really smoothly. Basically, the POS operator doesn't feel a thing when it comes back online. So it's really unobtrusive. And the big Vista system, of course, when POS goes online or offline, that's a big deal. That means the server's gone down generally. And usually a manager has to get involved because they'll have some operational things to work around. But in the VZ world, we had to refocus that. And I think that's an important thing to be aware of, is you may need to actually change some of your user experience to cope with this environment. So the other thing we mentioned that was kind of an important thing to do if you've got a desktop app in the mix is deployment. Okay, so we focused on this quite closely. You do want to make sure that the user's sitting there and he's found your cloud application and he's in the safety of his browser and he's got that full cloud experience going on. And then all of a sudden you spring it on him that he's got to install something on his desktop. So we don't spring it on him. We sort of introduce him to the idea gently. But also we tried to build an installer that was really clever and did a lot of work for the user just to make it super easy, and we tried to make sure that things like the user experience were really well tied to the web experience as well. So you want to make sure it's not scary, and you want to make sure that it gets taken care of. Of course, you need auto-updating and all those great features as well. So making anything easy like that in software, of course, is not easy, and it requires some pretty clever software and quite a bit of thought.
Thanks, Grant. Okay, when you install VZ POS, you actually don't. You install the VZ launcher. The VZ launcher is a very small piece of software that can install, upgrade, or otherwise maintain any of the applications that come as part of the VZ suite. So you go to vz.com, you go to your back office, you download a setup package that actually says this is setup POS, but it's not, it's actually the launcher. You bring it down, install it, and then you get a couple of desktop icons, one to run POS and one to run the configuration wizard. When you run POS, all VZ launcher first does, it says, I'm running from this VZ account, I want to run this application, POS, and it goes off to client management and the VZ client management environment and says, right, for this account, firstly, are they allowed to run POS? And if they are, what version number should be installed? It then checks locally to see what version number, if any, is installed. And if it needs to, brings down an application archive to then install POS and then executes it. Now, application archives are compressed files. They're zip files containing every single file, including all registry changes, because remember, this is a desktop app that sometimes uses registry changes and uses various different things and all the ugliness sometimes that involves. Brings the whole thing down, applies that change or applies that update, and then executes. Application archives are standard across all users of VZ. There is exactly one current application archive for POS, for example. There's also one for the POS configuration utility. It makes it really easy to roll updates out and stuff like that across all clients. However, we did actually architect in the ability to have a bespoke application archive for an application for one or more accounts or one or more users. The reason is that if someone comes to us and says, we want to pay you to make a change to put certain specific functionality into POS, for example, but it's just for them, that means we can use exactly the same approach we use for everything else to roll out a bespoke version of POS directly to one client. Okay, so it's really quite straightforward. Now, we also support a concept of application overlays. Now, these are country-level things, and they're usually used to do things like set up the credit card processor for a given country. So there's a different credit card processor in New Zealand than there is in the US, for example. On the screen, you can see screenshots of our POS configuration utility, and our overlay is used here to allow the different configuration parameters for the different payment providers to get set up for different countries. Now, we use all of our application archives are stored in blob storage, and we use the Windows Installer XML toolkit to put together the initial launcher setup. The reason for this is if you've got one magic launcher that installs everything else in your stack, you really don't want to get to a situation where you ever have a problem updating that launcher. Okay, otherwise you're really in trouble. And the Wix environment allows us to sort that out very easily. Likewise, we use the .NET Installer Bootstrapper to make sure that, as is often the case, if a client decides to try and install POS on a fresh out of the box, brand new XP-based POS machine, they've got nothing installed whatsoever. We want to get all of our requirements installed easily and first time. The last thing we want to do is display a list of, now, could you go to these 7 websites, install all this software, then come back and do it again, please, because the attrition rate would probably be beyond 100%. Okay, so we need to get that stuff sorted out. Really straightforward, really easy. So, we've got a client app. We've got all of the things behind it. We understand how we talk back to VZ itself. But what we need to do is make sure we've got a really easy way of getting all of our databases provisioned. Because as Grant said, we've got a database per Azure client, okay, or per VZ client. So after an Azure user or Azure client has been signed up on vz.com, they get verified to make sure we know who they are. And then our auto-provisioning scheduled task kicks in and starts creating their client database. Now, the first step for this is to figure out what language this VZ account's going to run in, because we have one model database per language. There's a model for English, there's a model for French, there's a model for German, for example. Okay. Inside this database are only a couple of things. One is our entire schema and all of our stored procedures and so on. The other thing is some textual lookup reference data, which never changes within one language, such as the words credit card, or something, or those sort of things, okay? So these things are absolutely guaranteed never to change for a language. Step 1 to provisioning a database is we simply copy that database and we create a vanilla client database. Now, every single country in the world is going to have different things that need to be set up as far as POS is concerned. And POS is a very, very configurable beast, okay? It's got a lot of settings you can configure. One of those, for example, is the minimum unit of currency that's available within the country it's operating in. So, for example, within New Zealand, it's 10 cents. Okay? So we have a country-level provisioning script that gets applied to this client database, and the result of adding one to the other is a usable client DB. The moment you've got a green DB here, a usable client database, you can run back office up against it, you can run POS against it, you can go wild and start using POS. Now, we wanted VZ to be really straightforward and quick to populate with data. The last thing we wanted to do, as Grant mentioned, is having to have every single one of our users set up small Coke, medium Coke, large Coke, popcorn, large popcorn, You know, it would be a really dull exercise to have to do. So we have these country-specific reference databases. A country reference DB has got films in it, it's got concession items, it's got ticket types that are the sort of things that every single cinema within that country is going to need to sell. Setting up a client DB, you should be able to get up and running within 10 to 15 minutes, and you're actually running POS within that time period. It's an extremely quick process. We can also set up individual different country references or individual client reference level databases, should we need to make sure that we can actually have this bespoke functionality across the board. We made a mistake here, okay? This is where we put our hand up, step 1. We ended up having a situation whereby the provisioning script had some data in it, such as distributors. The client DB could have client-created distributors, for example, and the country reference database has got references to distributors as well. In other words, we've got a bit of a data mastering disaster heading our way at some points, okay? We've managed to work around it, but we're re-engineering certain parts of it. The idea behind this, or the message here, is that provisioning DBs is actually quite straightforward. Mastering data, not so much. So you need to sort out your strategy as far as data mastering well before you get to the point of actually trying to implement it, okay? We're reworking some parts of this, but it's a lesson we've learned on the way through. So you've got a client app in place, you've got an auto-provision DB in place, now we need a back office app.
Okay. So this presentation isn't really about building greenfield web applications to run in Azure, so we're going to kind of gloss over this pretty quickly. We needed to build a back office system for this project, of course. And so we decided to start clean and fresh, as we said, and we really focused on user experience here as well. So we knew we had a different target user here. So we're going from being the duty manager or cinema manager working a shift to being the owner of a cinema. So we built in more executive dashboarding and stuff like that to cope with that target user. We also knew that a cinema owner is the sort of guy who's going to go home and work at home as well. Or he might be sitting out on his yacht in the harbour and he's got his iPad or Surface, I should say. And he wants to check out what's going on in the cinema, wants to be able to check on stats and stuff like that. So we didn't want to put any plugins into it. We didn't use Silverlight or Flash or anything like that. So we ended up building a very extremely rich JavaScript-based web app, which is great. It's really nice to use. I do recommend you go and have a play around. Someone from Vista should be able to hook you up with an account, probably, and you can go and have a play. It's beautiful to use and work with. If you're going to go down this path, definitely recommend getting a good JavaScript guy. Okay, we know one, so we can hook you up if you need us to. But it's great. It's a beautiful application. What we've found is we've been able to take a lot of the architectures that we've used here and reuse them in Big Vista software too. So at the start of it, we just looked at it and went, okay, well, let's get all the flashiest, newest, coolest acronyms we can find and throw them all at the developers. And they went crazy and did it. And for me, having been working for Vista for a long time and working with some of our older software, one of the biggest pluses I see out of these newer architectures is the ability to test everything. So that test-driven development approach and using dependency injection to be able to create those really incredibly great test coverage stories. Really good for us, and we're reusing that in Big Vista as well. So that's cool. Now, any back office management app like this, of course, needs reporting. It's one of those things you just can't escape. Okay, sooner or later you're going to need good quality printed reports. You're probably going to need to schedule those reports as well, and we'll talk about scheduling a little bit nearer the end. So Big Vista, we had a really large investment in Crystal. I don't know how many people in this room use Crystal a lot, and I know you all love it, right? Everyone loves Crystal? Yeah. So we thought this was going to be pretty easy. We thought this was going to be an easy win. We'd just be able to take a bunch of our stored procedures and a bunch of our reports and just run them up. We already had a Crystal report scheduling wizard that we have of our own and stuff like that. We thought this is cool. We'll be able to use it all. Not so much. So it turns out that Crystal and Azure don't really play nicely together. Crystal is still a bunch of COM libraries at the bottom of the stack, and they won't play nicely with Azure unless you want to use a VM role or do some fancy startup scripting. We didn't want to go there. So we had to look around for an alternative.
Thanks. Okay, so early on we decided we were going to use SQL Server reporting services with the web report viewer control set to local processing mode. Now, the local processing mode basically means that you take the web report viewer control, you give it a report definition and an RDLC file, you give it a load of data from the other side, which you're completely in control of providing that data, puts them together, gives you a report. Fantastic. The idea behind doing that was that we ended up having to write reports that first sometimes accessed local client database data, other times accessed client management database data for things like invoices, for example, and also in the future, quite likely is going to need to access some table storage data as well. So we needed to be able to chuck anything at these reports and make sure it was going to render the same way. So it was a pretty good, safe bet to go for the local processing mode report viewer control. However, the web report viewer control will not work within an MVC environment. And as Grant just had on the slide before, we're a full MVC app. So we've got one little corner of our beautiful MVC field that will forever be web forms. Okay, so we're sitting in there with a little bit of a hybrid architecture, which is not too ugly, but it just stands out a bit when you look at it. Likewise, there's a hotfix required to run the web report viewer control successfully on Azure. Okay, so that adds to our startup times for our web roles. So again, not brilliant, but we live with it. Okay. The web report viewer control uses a session to handle paging between different pages of reports. And at the time, we were using the shared cache on Azure. Now, the web report viewer control is extremely chatty with the session state, and it puts some large objects into that session state over a period of time. The result was one person using our reports could actually bring down our entire shared cache in about 30 minutes. Okay, not great considering the rest of our app also relied on that shared cache, so the whole thing came down. So we moved away from using the shared cache for a session state for the report viewer control, and now we've actually moved to dedicated cache throughout. So if you're going to use this, don't go anywhere near shared cache, okay? Now, as well as the reports, obviously, from Crystal that we needed to convert, we needed to move the stored procedures across. The stored procedures were using select intos in quite a few places. Obviously, that just needed to get fixed. But they also had some concurrency issues where they wouldn't work particularly nicely with multiple sites running reports within the same DB at the same time. So we had to fix some stuff there. But the end result was that we had a spec for a given new report, which was effectively the sum total of an existing crystal report plus a stored procedure. Now, some of these stored procedures are thousands of lines long, and the crystal reports are not simple either. So in other words, there was a huge window for messing stuff up, okay, and misunderstanding exactly what was the requirement here. As a result, there's a fair amount of rework. All right, so yeah, reporting looks easy, it's painful in some places. Now, in order to try and get some of our crystal reports across to SSRS reports, we decided to use an online conversion service. Hey, that sounds easy. Let's just send 17 reports across and get 17 reports back, yeah? Well, there are quicker and definitely more satisfying ways of burning your excess money, okay? Now, basically, we got back utterly broken reports, and even if they did work, they used approaches that no sane person would ever use with SQL reporting services right now anyway. So it would have taken more work to fix them than it would have taken to start from scratch. So that's exactly what we did. We binned it, and we just came straight back again. Okay. Right. So what does it look like? We've gone through client apps, we've gone through the DB, reporting, web apps, and the whole 9 yards. Okay. And this is basically what we've ended up now. In the top left-hand corner, you've got the VZ Global Client Management. Absolutely everything that has got something to do with authentication, security, billing, running and managing VZ lives here. Absolutely nowhere else. Okay, this is the control center. It's the heart of all parts of VZ. At the bottom right, you can see all the different regional instances. Originally, VZ was designed to have multiple regional instances. For example, the first one was always designed to go into the US South Central. After that, we thought we'd go to Europe. Then after that, Asia and so on. As we got more and more clients from different areas, we were going to move or deploy a data center, a regional instance down into that area to get really good performance. However, our performance optimization and performance running has been so good against the US South Central, it looks like we can run the whole planet out of one regional instance. We can just scale it out. Okay. The architecture supports having multiple regional instances, but the chances are we won't have to go there for performance reasons. We probably still will go there for China rollouts, but that's going to be a more political reason rather than a technical one. Okay. However, the ability is there for us to move stuff around should we need. Okay, so nice to get a good surprise. That means you can keep your overheads down and just roll everything out in one area. Off system, we've mentioned Pingdom already. This is the purple bit. SendGrid is our SMTP server. If you're going to scale, you've got to have a really good scalable SMTP server. SendGrid is absolutely great at doing this. It's cheap, it's reliable, it just keeps on trucking and keeps on sending you mails. Okay, it's got some good value-added features. Now, Vista is well known within the industry for some really fantastic customer service, okay? And they use a custom-built and custom-enhanced support system within the environment, within the organization. We didn't want to chuck all that out, so therefore the VZ back office integrates whenever you want to log a support incident straight back into Vista support, so we can use exactly the same processes, same SLAs, same contact methodologies that we use for everything else as far as service is concerned. So, when POS wants to go and actually make a call, let's say it wants to sell a ticket, what does it do? Actually, well, let's talk about logging on. First thing POS does is it goes off to the client management web service and says, hey, this is who I am. I want to know where my regional instance is, please, because within VZ there is only one guaranteed, immutable, cast-in-stone address, okay? And it's the web services for client management. Everything after that is dynamic, and client management says this is where you go after you authenticate with me. Okay, so client management says, yep, I understand who you are. It gives POS back an access token, which identifies it from that point onwards, and also the endpoint at which it can hit the web service from there on in. POS says, thanks very much, I'm going to go and hit the regional instance's web service and passes across an access token. Now, the regional instance, of course, has absolutely no clue who this guy is, even though it's been given an access token. So the first thing it says is, I don't trust you at all. I'm going straight back to global client management and figure out whether or not it knows about this access token, and also to which database should I allow you to have access. At no point does POS ever tell the regional instance what database it relates to. Okay, it's only handled inside. Now, the other thing that client management does when it authenticates and validates this token is it throws the token away. Okay, it rolls the token over and issues a new token back to the regional instance, as well as saying, by the way, here's all the database connectivity information you need to go and talk to the DBs. And then the regional instance goes and talks to the client database. Thank you very much. When it gives the results back to POS, as well as the results of the request that that POS asked in the first place, a new access token can be part of the response. And our online provider knows that if it gets a new access token back, it has to respect it, preserve it, and use it next time. One of the good things about that is, if there's a man-in-the-middle attack at any point and someone grabs an access token, it's only going to be usable for a few minutes until we roll it again next time, okay? It doesn't stop it happening in the first place, but it makes it very, very visible when bad things start happening to different POSes. Okay, client management itself. All of the clients and applications on the left-hand side, every single thing authenticates against client management, every single app, okay? I want to call out just a couple of things in this slide. In the black area, the grey area in the middle, sorry, middle bottom, you've got the worker roles, and these are scheduled processes. We use locad.cloud as our scheduled task execution framework, okay? Every single app that isn't trivial needs to run stuff at a periodic basis. Is it credit card billing? Is it changing your password? Is it authentication? Is it database provisioning? Something like that. Locad.cloud is a really good little framework. It's open sourced, it's purely .NET. You can run this stuff up, you can change it if you need to, okay? And it runs really nicely and scales really well on Azure. Two things about it. Number one, configuration of it is a bit twitchy, okay? You need to be quite careful around how you configure it. It's great when it works. It's a bit of a hard thing to work with when it doesn't. Trying to debug that's a little bit difficult. And likewise, it doesn't work very well when locally deployed. It's not fully supported in a local deployment mode. So you end up debugging quite a lot, deploying new tasks up to Azure and then seeing if they work or not. However, when it's working, it gives us everything we need. In storage, in our blob stores, we've got email templates, report definitions, and help content. I've mentioned reports and installation archives already, but email and help, we actually have multiple language support here. We use a naming convention that's extremely similar to normal .NET resource files. So we have language-based help and also language and culture-based help. So we can go all the way down to that level should we need to. Okay, so we've got that structure in place, and we just roll out English first, and we roll out the rest following on. Now, part of the scheduled processes we use at client management are billing. Now, we used to have a slide in this deck for billing. We took it out because it's not specifically to do with Azure. However, billing is hard. No matter what anyone tells you, there are lots of offerings on the market, okay? We went through every single one when we did this. Every single company said they could do what we wanted them to do. Every single one of them failed catastrophically to give us what we needed. Okay? We wasted months investigating all these different offerings and ended up rolling our own completely from scratch, and now we can build any way we like in any model we like. Okay? I'm not suggesting you have to go and build your own, but make sure you take it with a pinch of salt anyone that says this stuff is easy, because it's really not. Last one before I hand over to Grant. The regional instance is where our web application lives. It's where back office lives. It's where our POS WCF web services live. Okay? And it's also where all of our third-party applications that integrate with us talk to. Okay? For example, we've got a digital projection system that talks to us, and we've got multiple other add-ons that are coming online. They all terminate here. They all work here. One thing to call out, we've got a couple or a few model databases per language. We've got slightly more reference databases per country. We've got lots and lots and lots of client databases, and that's the way you want it, because when you get client databases, you get money, okay? If you haven't got a model that looks like that, or you've got too many things at the other end, you've got some really bad overheads and you've got no revenue. That's not a great situation to be in. Okay, Grant's going to take us home.
Phew. That was good. Thanks, Chris. I just actually, before I do this slide, I realised we missed a couple of things, Chris. We've dropped the ball a couple of times.
Okay.
I forgot to mention that when we were talking about multi-tenancy, when we started that decision-making process, the feature for federation in SQL Azure databases wasn't available. And there is a session, I think Chris Alder's doing a session about that. So definitely, if federations were available when we were making those decisions, we might have made a few different decisions. The other thing that wasn't available was the reporting services.
That's right.
So that feature is also available now, and we may have made some different decisions along the way. But I guess what we've shown is that this wasn't probably the standard cloud application 101 presentation. We have taken a few side steps, as we've seen, from a classic cloud app playbook. And I guess that's one of the key things to take away is that's okay. It's okay not to be completely cloud in everything you do. You can make it all work. You just got to pick out the things that work for you and make adjustments where you need to. Also be aware of things that look easy. So things like billing, as we just talked about, and reporting, we thought those were going to be kind of easy. They weren't easy. Okay? So definitely I think the key here is to go and test your assumptions on a cloud platform. You do prototyping, think about what you're assuming is going to work out, go put it up there and try it and see what happens. It's really important. Also get help early. So there is a growing sea of expertise in cloud computing in New Zealand now, which is great. So Microsoft's own staff are really good. They helped us out a lot. We've got architectural reviews which are really useful. There's MVPs out there that really know what they're doing, and of course there's really, really good consultants out there like Chris who are available, and so you definitely use these guys. They're really good. Performance test, definitely get in there and performance test, especially if you're going to have a desktop app in the mix, if you've got this data farm model going on, you need to figure that stuff out early and figure out what you need to perform and what you don't, and that's important. As we mentioned, we realised there was a bunch of features we could just axe out and it didn't really matter. So we could take those out and we didn't have to work with those in terms of performance. Certainly keep the performance testing going. The Pingdom system is great for us. As Chris said, it's $40 a month. Keeps all our servers warm and it lets us know before our customers figure it out that stuff's gone down. It's great. And then lastly, something we didn't talk about is administration. Okay, so we kind of deprioritized building admin tools. We figured that it was better to get the app up and running and get it in the cloud and then get a whole bunch of customers before we worried about trying to build tools to deal with that scale. This has bitten us a couple of little times. There's some stuff you're just going to need. You're better off building it up front than getting your really good architects and developers and stuff like that doing service-based work and maintenance. You don't want to do that. So that about wraps it up. Anything else?
I'm done.
I think we're happy. Thanks for listening. Hopefully there's been a few nuggets in there that are useful for people. We're going to be around, as we said, if anyone wants to drill into anything a little more deeply, you want to talk more technical, there's Stephen and Chris are around to do that. If you want to talk about the commercial stuff, I'm here. I see our product manager is over here as well. He knows all the numbers. If you want to find out how many people are actually using our VZ product now. So we'll be around. The Vista, we're sponsoring the coffee stand as well, so grab a coffee, and there may be a few of us lingering around out there as well. Okay?
Thank you.
Thanks for that.